resuming where we stopped in the last class. So, I have already discussed with you the way the course delivery will be progressing. So, in the first week, as we discussed, that we'll be talking a little bit about the historical perspective of agriculture. So, if we look pretty early in the civilization, human beings were nomads. They used to move from place to place, gather food, and once the resources at that particular location get consumed, they used to move to another location. But in that whole process, somewhere down the line, mankind, or as a race, we learned to grow plants. We as a race were probably rearing animals much earlier than that. But after learning how to raise plants, then we did few selections over the ages. We kind of concentrated on few crops and few vegetables, few fruits, and such variations happen. So, in terms of the grains, in terms of the food, in terms of the fruits, in terms of the vegetables, happen across the world, different places depending on the availability. You have different kind of grains, different kind of vegetables, different kind of fruits, and of course different kind of rearing animals. But end of the day, what happen is that from a big pool of plant kingdom, from a big pool of animal kingdom, we chose a selected few. How and what made us to select those few is an unanswered question, but we did so. Like those ones we chose includes rice as one of the major grains, wheat, barley, millets, sorghum, then you have pearl millets, some of these. Similarly, we selected potato, cassava as source of sugar. We selected vegetables like brinjals, cauliflower, lettuce finger, beans. But if you look at the whole plant kingdom, you will see only handful of it got selected. So now, while you are doing agriculture, the idea was you wanted to grow only handful of them, and these handful plants have to compete with the rest of the plant kingdom. So in other words, if you think of it, it is something like this. Say for example, I give you this idea. So say for example, I have, say, these are the different A, B, C, D, E, likewise to Z. So I chose, say, C, D, E, and say Z. Now, what I wanted to do, I wanted to grow these for my staple food requirements. Now, if I have to grow them, then these other ones, which now I am encircling in red, they will be competing with these ones. So what we can do, once these one will be competing, so the first thing possibly what happened in agriculture development is clearing up the land from all other A's, B's, D's, and likewise. So now you have a piece of land out here as shown in arrow, which is free from other plants. In other words, you have the other form of biomass you are now getting rid of. Now you exclusively wanted to grow your either C, E, or Z. So first of all, you have to ensure that this competition between inter-competition is being reduced. That you did by physically isolating or removing all the plants. But still, there will be some which will be more hardy, more stronger, which can compete with your selected ones, the chosen ones. And those chosen ones which can compete with those other ones which can compete with your selected ones will always pose a threat in the production line of your C, E and Z. And those are what we term in technical term is weeds. They are also part of the plant kingdom, but they will compete with your chosen crops, and maybe they are much more stronger in terms of genetics, in terms of the physiology, that they can outsmart your chosen crop. This is one example I am giving where slowly we'll realize how we moved or marched towards modern agriculture. Now, let's take the second situation. So, here you have a finite land of a finite dimension. Now, in this land, you have a topsoil where things grows, okay, and which has a simple dimension which you can cross check in any soil science book. Now, the thing is that finite volume of soil, that finite volume of soil has finite amount of different elements. In other words, that finite soil will have a fixed amount of carbon, nitrogen, hydrogen, sulfur, boron, zinc, molybdenum, manganese, and this list can go on. And they will not be freely available. They will be in some form of complexes. And the plant what you are growing has the ability to derive those components from this soil. So, you grow a crop for a season, you grow a crop for a second season, you grow a crop for a third season, you grow a crop for a fourth season. Eventually what will happen, this particular piece of land, unless otherwise we supplement these different elements, will be depleted of those elements to the level where plant can't extract more. They may be there, but plant won't be able to extract more. So, what you have to do is you have to supplement this. You have to supplement this thing with those elements. And the very moment we talk about supplementing this, we are talking about the world of chemicals, world of fertilizers. Okay. So now after weeds, let me introduce something called fertilizers. Now, a third aspect now I am going to introduce is you have chosen or you have a chosen few. Say for example, you have C, E, Z, and now that C, E, Z, those are your chosen crops. You are growing them over acres, and hectares after hectares you are growing them. Now think of it for a minute. In a natural setting, how that looks like? In a natural setting, you have things going like this: A, B, C, X, Y, Z, P, Q, R, L, M, N, O, P, X, Z, likewise. So, this is a natural setting where things are growing. So, there are insects, there are different form of insects which feeds on these vegetative kingdom or into the plant world. Now, for an insect, say for example, I denote an insect out here. Insect say X or say I prime. For this insect, most likelihood it has multiple possibilities. It may prefer Y and maybe a closer relative of Y may be X, or maybe a closer relative of it say Z. Similarly, another insect I say I double dash, it may prefer say A and a closer relative of A say B and maybe a closer relative of C. Fine. Now, I take up another example, say I have insect I triple prime. So, this may prefer O and a closer relative of it say P may be closer relative of Q. Now, if I from here chose only handful of plants, say for example, this example let us take I chose C, I wanted to grow C in as a crop, I wanted to grow X as a crop, and I wanted to grow say O as a crop. Okay. So, these are my crops, and now I increase the area of these crops. Many-fold, many-fold increase. Okay. Acres after acres, hectares after hectares, I am growing only now your either C, X and O. And the way I grow, probably a lot of C's like this, lot of X like this, lot of O's like this. Now, in the system, insects are the same. Now, for an insect, think about yourself in this situation. For you, here I come, I say I am the insect I prime. So, I have to hunt down where is, so my choices are X, Y, Z, fine. Now, I have to hunt, I have to come here, then I have to hop down here for resources, I have to hop down here and likewise and so forth, which is a lot of work for me. Similarly, for I double prime, I come here, I hop to here, I from there hop here, my family and everything, and similarly for I 3 prime. So, come here, then move here, here. Now, if I see that I prime the insect whose target is X. So, which one I will prefer? Shall I go here or shall I come here? Because if I come here, I know all the plants are X, 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 likewise. So, for me to acquire resources will be much more easy out here. Similarly, for the O, I triple prime. So, you have a lot of O's. So, in other words, what we are saying is the modern form of agriculture, what evolved through the ages since mankind learned how to grow crops, has believed in the word called homogeneous or homogeneity. Yet, nature is a heterogeneous mixture. Yet we know in a heterogeneous system, you cannot really feed a timid million. So, your options are very clear. You will have this strategy out here and you have to work around it. Now, in order to counter your pest in the form of insects, and by the way, this could be even microbes. Instead of say I can put it as M prime, M double prime, M triple prime. So these are the microbial infestation, okay? And they may have their own targets. Now, in order to counter this, we started developing this set of chemicals, which after I introduce weeds, fertilizers, now I introduce the third thing, which is called insecticides and pesticides, which will be countering our unfriendly neighborhood, which is okay. Whereas I did not mention here regarding the weeds, in order to counter the weeds, we have different form of weedicides. Herbicides. So these herbicides, weedicides are fairly specific to the wheat plants as compared to the crop plants. So they are also very, very specific chemicals which ensure that your weeds die out, not the crop plants. So you see, in this little discourse, we are realizing as we as a race mature to become extraordinarily advanced agrarian society, we almost unconsciously became dependent on things which maybe nature has seen, but nature has never seen them in such a huge quantity, because now from nomads we became settled societies. The evolution from nomad to human society, a journey whose origin is learning how to grow plants, and which led to extraordinary diverse kind of development in the field of agriculture. But that came because we kept on discovering, kept on developing different form of compounds which either help us to replenish a depleting soil, because see, we are no more nomads. So that whole strategy, we do a cropping at a particular location. So there are this kind of things also used to happen at one point, like the tribes are moving out here, they grow, they stay there for a while, then grow crops, and then they change spots, they move to next place, there they consume the resources, then they move to a third place, they burn it. Whereas the place what they have left behind, over a period of time, again by nature's action regain its fertility and all other natural resources. Okay, but that means if this kind of theory goes, then we are talking about something which is unheard of, is called moving cities or moving civilization. Yet we know, when we talk about cities across the world, New York, San Francisco, Delhi, Madras, Bombay, they are cities. They cannot move on from place to place. They have to supply with, there has to be a food chain. They have to be continuously fed in and around. So you cannot, and at a particular distance, say for example, we talk about Delhi, or we talk about Bombay, or we talk about Madras. So you see, surrounding these cities, you have the agrarian societies, which are continuously, they are the pipelines which are continuously feeding these cities. So it cannot happen that city will move along the pattern how we do agriculture. So what are your options? So this option is gone. You cannot move, and this is what has happened. So in and around the cities have developed, and this land has, the land is finite, okay. So this land has to feed not only itself but the surrounding cities, surrounding urban civilization. What are your options? Your options are in the previous page. You have to depend on these parameters. Reduce the competition from your selected crops. Weedicide, herbicide, fertilizers, insecticide, pesticides.